Hello guys, we are back with our next lecture. In this lecture, let us go through the next concept. So the concept is a single source shortest path, and in that we will be discussing about the first algorithm, that is a Dijkstras algorithm, guys. Okay. So in graph theory, the shortest path problem is the problem of finding the path between any two vertices or nodes in a graph, such that the sum of vertices of its consistent edges is minimum. So here in Dijkstras we will be using weights are positive and directed, guys. So in single source shortest path means, so from a single vertex, like assume there are having total 10 vertices. So from A you will find the distance for each and every vertex, guys. So in total 9 vertices distance you will store. So this concept is nothing but a single source shortest path, guys. So now you are getting the idea, right? Yes. Okay, so instead of going through the code, so first let us go through the problem only. Okay, so I think everyone watched the Prim's algorithm, right? Because Dijkstras algorithm is a code twin of Prim's algorithm. So it's a twin, like some kind of similarities are there in between both of them. Okay, so that is the reason why I'm asking you to watch that lecture if you haven't watched it, guys. Okay, yes. So anyway, let us start. I think even if you did not watch it, you can continue, guys. Okay, so there's nothing much crazy. Okay, yes. So let us start. Okay, so here our question given is, so they are asking to find the path from P to U, and they are also asking the cost and the path, the minimum cost path. Okay, yes. So let me draw the diagram first. So P, Q, R, S, T and U. Okay, so remember, whenever you want to apply Dijkstras algorithm, the graph should be a directed graph and the weights should always be positive, guys. So if they are negative, it is always a better option to apply flood Warshall, guys. There is one more algorithm called flood Warshall. You can apply that. If you are applying this algorithm, it's always better to have weighted and positive weights, guys. Okay, yes. So even though you are having negative weights, you can apply, but it's not guaranteed answer. So you can get some loops and you can end up with some wrong results at the end. So that is the reason why it's always better to follow the rules, right? Yes. Okay, so here also you will be maintaining a table. Okay, so one is for distances. So here we are using a d of a v, and for parent we are using a pi of v. Got it? Yes. So now our values are p, q, r, s, t, u, right? Yes. So here I am trying to find a path from p to u. So from p I am trying to u. Got it? Yes. So from this you can directly say that which is our first vertex, guys, our starting vertex. So our starting vertex, so let me keep a book aside because it will reduce confusion, right? Yes. So what will be our starting vertex? So p to u means p is our starting vertex. So 0. Okay. So again the same situation. So initially you will apply infinity for all and nil for all the values. Okay, so now let me change the pen color so that will be clear for us. So let me take blue color, guys, because blue will be easy, right? Yes. So the initial value of p will be 0 and the parent will be nil. Okay, so now what you do is, whoever are adjacent to p, update those values, guys. So to p, who are adjacent, q is adjacent. So what is the cost? 1. And who is the parent? P is the parent. So via p I went. Okay, so from P anywhere else I can go to S also. So here the cost is 6 and here the path is a P. Nice? Yes. Okay. So moving on. So from P can I go anywhere else, guys? I think no, right? Yes. So now let us concentrate. So this is the place where there is a small change with respect to Prim's and Dijkstras, guys. Okay. So now we are done with the P, right? Yes. So let me cancel this P, guys, because I don't want to have any further confusions. So that's the reason why I'm striking it off. Okay. Yes. Okay. So now what you will do is select which is minimum among all these values. So which is minimum? Q is minimum. So first strike off Q. Okay. And check from Q wherever you can go directly to R. So means you can update this to 1. So instead of updating it to 1, calculate the cost with respect to Q also. So till Q, how much it is the cost, guys? 1. Okay, so whenever you are finalizing, please write the values above, guys, because that will reduce confusion. So 1 plus 1, it is a 2. So to go to R from P, you need a cost of 2 rupees, right? Yes. So 2 by via whom you can go from? Via Q you can go. Got it? Yes. Similarly for S also you can go via Q. So this will result in a 5 and via Q you can go, right? Yes. Okay. So now which is minimum? R is minimum. So now let us strike off R and let us write the value here. So from R you can go to S. So the cost is 4. Okay, so this is really great. The S cost is being completely reduced R. Okay, so to u also you can go. So 2 plus 1, the cost will be 3. So via r you can go. Got it? Yes. So now this looks really good, right? Yes. So now you reached till r, sorry, till u, right? Yes. So now among these two, which is minimum? U is minimum. But if you observe carefully, from u can you go anywhere, guys? You cannot go anywhere, right? So this is done, but there's no update in the table. So directly you ended up with yes with the t 4 value, right? Yes. So now this is the minimum value. From yes with a cost of 3 rupees, you can go to t. So 3 plus 4, sorry, 4 plus 3, that is 7, and via yes you can go, right? Yes. So what is our question? From p you need to go to u. So we are done with the whole question, right? Yes. So from u, let us track back, guys. So to u, how you went? With the help of r. To r, how you went? With the help of q. To q, how you went? With the help of p. So this is our result. So p, q, r, u. So p to q, q to r, r to u. So this is the path, and the cost of that path is 3. Okay, yes, 3 units or 3 rupees or whatever you want to call. Got it? Yes. So it's a quite easy problem. The only difference between Dijkastra and Prims is, in Prims we used to write the values directly instead of adding them. So here we will add them, guys, because here we are trying to find the distances, right? So that's the reason why we will add them. That's a simple logic, and it's really easy, right? Yes. So I hope everyone got a clear idea, right? Exactly how we are working with this. So now let us go through the algorithm. Okay. So Dijkastra algorithm. So G comma W comma S. So G indicates a graph, W indicates the weights, and Q indicates, sorry, S indicates the start vertex. So where you are starting. Okay. So firstly you will be starting a for loop. For each vertex, V belongs to V of G. Okay. You are initializing the values to infinity to nil. So basically for each and every vertex in our table, you are initializing the values to infinity and nil. Okay. So once that is done, okay, so you are initializing the first value to 0 and the solution to 5, and then you are pushing each and every vertex to our priority queue, guys. So this is a priority queue. Okay, so once you have successfully pushed them, so you will continue until your queue is empty. Okay, so what we are exactly doing is, in priority queue you will take the minimum value, okay, and you will add it to the solution, and you will start calculating its adjacents. Okay, and in here you will be comparing whether our existing value which is less. So is the new value which is less. So basically if you observe, so previously for yes, okay, the cost is 5, right? Once r is introduced, with the help of r you can go at 4, right? So means a new weight is a lesser, right? So that condition is passed, satisfied. So you will be coming inside and you will update the value. From 5 you updated to 4, and even the parent also you updated from q to r. So in that way you will update, guys. So in this way the whole algorithm will work, guys. So in that way you will do at each and every node, and until the queue is empty. So basically until you get them all the elements out of your queue. So here to represent queue I was striking the values, right? Yes. So that's what we'll be doing, guys. Okay. Yes. So this is about the Dijkastra algorithm. So you got an idea, right? Yes. So I hope everyone got a clear idea. So in the next lecture, let us discuss the next algorithm and the last algorithm for the subject algorithms. So the next topic is a Bellman-Fold, guys. Okay, Bellman-Fold algorithm. So let us meet in the next lecture. Thank you. Thanks for watching. Like, share, and subscribe for more awesome videos like this. Thank you.